In the last section, we figured out how to define a function that took a struct as a receiver. So we defined the print function and the update name function, both of which had a receiver of type person, and so we were then able to call gym.updateName and gym.print solely because gym is of type person. We then ran this update name function, and we saw that if we attempted to update Jim's name right here and then print out Jim immediately afterwards, it appeared that the update did not actually take hold. So in this section, we're going to dive into that really deeply and try to understand exactly why updating Jim's name did not actually take effect inside of our application. Now, this entire topic is going to be revolving around the idea of pointers in Go. If you are familiar with pointers already from working with C, C++, or any other type of language, well, it's very likely that you might not like pointers a lot, but don't worry, pointers in Go are relatively straightforward and really not the worst thing in the world. So let's jump into this and let's figure out exactly what's going on. Okay, so we're going to walk through our code here line by line, but before we do, I want to give you a quick refresher on how RAM or how memory works on your machine, on your computer right now. Now, as we're talking about RAM, I'm going to give you a somewhat non-scientific definition. So I'm going to give you just kind of a very sweeping broad strokes overview on how RAM works, because I want you to think more about what Go is doing right now rather than doing a 20-minute dive on how RAM works on your local machine. So all I really want you to understand about RAM right now is that memory on your local machine can be thought of as like a bunch of little cubbies or a bunch of little slots or a bunch of little boxes. Each box in your computer's memory can store some data, and each one of these little boxes or these little value containers has some discrete address. And so whenever your program says, oh, I want to retrieve some information from the computer's memory, it goes and finds some address, and then it pulls the value out of there. And so each of these little boxes right here can contain some amount of information. And that's really all I want to talk about as far as RAM goes right now. Just quick overview on exactly how it works. Okay, so let's now take our program apart step by step and kind of think of how our program is working with RAM on our local machine. So we're going to first start off with this line where we create a new struct of type person and assign it to the variable of Jim. So when we do this, when we create this new struct of type person, Go will create that struct. It will then go to the local memory on our own laptop or our own local machine, and it will attempt to find some container or some spot that is free and has the ability to accept some data. So we can imagine that Go takes this struct right here, it goes and finds some space or some location to place that struct, and then it shoves that data into this little container right here. And so we can imagine that this Jim struct right here, or this person, is sitting at the address of 0001. And so whenever we look at the variable Jim, Jim is pointing directly at this little container right here. And so if we print out the value of Jim, we're always going to see exactly this value right here. Okay, so with that in mind, let's now think about what happens when we call gym.updateName with Jimmy. And I also want to think a little bit about that receiver that we created on the update name function right here. So we still have Jim right here, right? Jim is still at 001, and it's still that same exact struct. Now here's where things get really, really interesting with Go. Go is what we refer to as a pass by value language. Pass by value means that whenever we pass some value into a function, Go will take that value or take that struct, it's going to copy all of that data inside that struct and then place it inside of some new container inside of our computer's memory. So when we pass Jim into this update name function, Jim still exists by himself as this struct with the first name of Jim at address 0001, but Go copies that value, it finds some other container that's empty, and it stuffs that copy into that container. And then it runs the code inside of update name with this receiver P pointing at that copy. And so when you and I modify that field of first name inside of that function, when we run this code right here that says p.firstname is going to be new first name, we are not updating the original struct of Jim. we are updating the copy that was just made for our particular function call. Now this might sound, first off, it might be confusing, which is totally fine, completely to be expected. And then number two, it might seem crazy, like, why in the world does Go do this? Why does Go make a copy when it passes this data off to this other function? Well, there's a lot of good reasons for that, and we'll learn about some of those reasons in a little bit. But for right now, I want to first focus on how do we rectify this issue? Like, clearly, at some point in time inside of one of our programs, we're definitely going to want to do something exactly like this right here, right? We're definitely going to want to define a function that takes some argument and then updates the struct that the function is accepting as a receiver. So let's take a quick break. We're going to come back in the next section and we're going to figure out exactly how we use pointers to solve this issue. So quick break and I'll see you in just a minute.